Okay, I think that we can start. So maybe I do a little introduction to this next part of the program. So we are now talking about the national exploration programs. So I imagine that some of you may not know what it is. So a national exploration program is something that member states have to prepare according to Critical Raw Materials Act. So every European Union member state has to have a program at the moment, or alternatively, they could present this scientific like reasoning why they don't have any potential, and so they don't have to prepare a program. And so now we are going to give an overview of the programs of Estonia, Latvia, and Lithuania, and we also have a small change in the program. I mean the program of the day. So we start with Lithuania and continue with Latvia, and Estonia will be last. So the opposite way as we planned, but it's all right. So please, Jurga.
So hello everyone, can you hear me?
Let's wait to Jurga.
Yeah.
Yes.
Okay. So it's a big pity that we cannot with my colleagues be here. It would be we will be very happy if we could present it alive, but anyway. So, and as you see, here is a shot. So the presentation is prepared by myself. I am Jurga Lazauska, and also by my colleague Jolanta Čižienė. She is also remotely, and our colleague Simonas Danielius. And you see short overview what I tried to implement. So I do hope you had an exciting day, a lot of rocks, so now a little bit higher European level regulation. That's also important part of our research life. And the presentation, it's called not National Exploration Program, but as you see, and it's more exact to what we are doing. So implementation of, I shortly will call this Regulament, Critical Raw Materials Act. So, and Article 9, because the Act itself covers much more wider than the extraction of just, critical raw materials from subsurface. And short also introduction about how it works a little bit while I'm talking. I'm boring you with some definitions, only some from the Critical Raw Materials Act. For those who are not very familiar, so there are, I think, 5 pages of definitions, and that's if you read a little bit different from, let's say, purely geological point of view. So the as it was already introduced, so and overall, this Critical Raw Material Act sets a benchmark for all European Union to increase extraction of strategic raw materials to meet at least 10% of Union's annual consumption. But it means it comes strategic raw materials from everywhere, from batteries, from waste, from shells of mussels, from everywhere. So just to be not so boring. And we are now, perhaps all 3 countries, talking about the implementation of Article 19 and exactly parts 1 and 3, which requires the member states to establish national programs for exploration of critical raw materials. And what is concerning geology is only this definition, but also I pointing here that it's any single minerals occurring in any mass or deposit of potential and economic interest. And economic interest in terms of Critical Raw Materials Act is interesting. If one would be interested, open the annexes. There are purely economic equations, and talking even to experts in overall, no one really knows what by the end would set as economic interest. It's not just PPT or any units what our geologists are how to say, used to talk about the occurrences or deposits. And also what is national program, also you read shortly, but it should cover entire territory, also interesting, and the general and targeted exploration, what could be different from what is perhaps defined, or at least in Lithuania, it differs what is defined in our legislation. Yes. So yeah, we go. So also, what is reglement? So reglement is the strongest, I would say, European Union legislative act, and differently from all directives, etc., it has to be implemented without transferring to national legislation, exactly on the terms what is defined in the reglement. So this Critical Raw Material Act came into the force 2024. Lithuanian government only by 3rd September of 2025 approved a resolution about the implementation of this act in Republic of Lithuania. This is also a long document with different organizations authorized for different what is in the Raw Materials Act. But what's concerning geology, so one sub-item of this regulation mandated Lithuanian Geological Survey and the Ministry of Environment to prepare and approve. At that time, it sounded Lithuanian National General Exploration. The terms are exactly from a reglement, a program for years to 2026-2030. So in the reglement was that each member state has to prepare and approve this, I will use the slang, so NEP, National Exploration Program, NEP or NEP, by end of the July of 2000, May 2025, what Lithuanian Geological Survey done before it was authorized or mandated, but it was approved due to the legal issues which were going through higher level of ministries only on the end of the year 2025. And yeah, so actually it started only like real work from the beginning of this work, of this year. But it should be emphasized what I showed here, that it authorized only Lithuanian Geological Survey, and there is no financing at all, dedicated financing, no human resources. So it means that we, apart from what survey and our people are doing, we have to implement this program of our all, both financial and human resources, and this is a challenge. And yeah, so this is how it is. Now coming to the more maybe interesting, so to the content. So once again, what you see here, so Article 3, Part 3 of the Article 19 says, so that where member states' geological conditions are so that there, with a high degree of certainty, there is no deposits of critical raw materials, so they carrier minerals will be identified through the measures listed in the paragraph 1. In such a case, it may consist of scientific evidences to that effect. And actually, there are very strong measures listed, but here, this is also regulation. So, facts, Lithuania currently lacks of a high degree and comprehensive analysis, so high degree of certainty, and lacks comprehensive analysis of geological data that it be possible to implement all the requirements from the Article 19, Part 1. Because there is no reliable information regarding the presence of such critical raw materials or carrier minerals or specific characteristics, and here what absence of this evidence is even scientific evidences for the entire territory of Lithuania that led at the let's say, current states when its program was prepared to produce detailed critical mineral maps. That's the definition from reglement. So identify exact locations for direct scientific research, such as geophysical surveys. And there is no enough data for create predictive maps. And I already defined the predictive maps. Come back to mineral occurrence and coming also to the economic value of the layers or deposits. So we are currently at the stage of collecting, reprocessing existing geoscientific survey data. And so look what is major aim for all this. Obligations from reglement are identified mineral occurrences potentially containing cadmium minerals. So up till now, in terms of explored, is only one generally or preliminarily explored iron ore deposit. You see here in the southern Lithuania, in our resort area, as you see quite an area about 100 hectares, and there are estimated generally explored resources, 61 and more than 5,000 cubic meters of iron ore, and prognostic resources. So this is different classifications, and prognostic resources less than this, about 57,500 cubic meters. So this deposit has been explored during the campaigns of crystalline basement mapping, predominantly occurring by that Soviet times, different name, geological surveys, so a crystalline basement and another. So usually the mapping was carried out from starting 1973 to 1988, 93, so first years of independence. And here you see mathematic models of this deposit with possible, so iron ore is hosted mainly by serpentinites and altered carbonites, and magnetite is a major ore mineral. So this is only one what we have in terms of, we can call, even by definition of our legislation and by definitions of reglement, generally explored deposit. So there are, according to the knowledge, there are three, what I could say, types of objects, different geological layers or objects, which might have potential of CRM carrier minerals in terms of reglement and recent technologies and recent views. So the most explored and most perspective to today's knowledge is crystalline basement, as I said, previous mapping identified in not just in Varena iron ore, but in southern Lithuania, occurrences of some rare elements and higher concentrations, anomalies of copper and molybdenum. So another possible source could be groundwater brines, high mineralized, more than 35 grams per liter, is recently considered as potential source of hydromineral raw material. So quite recently this year, for example, Germany announced even like deposit of, if I recall, bromine or boron in the high mineralization brines. So in Western Lithuania and Cambrian brines, there were recorded traces of bromine, potassium, iodine, boron, lithium, and strontium. And sedimentary cover, if there are technologies, if there would be criteria of economical value, we have dolomite layers, which is actively mined in northern Lithuania, so it could be a primary source of magnesium under certain conditions. So also in Lithuania, the lower part of the upper Cretaceous Cenomanian layer, which is about very thin, half of a meter, but covers quite a big territory. So there is a thick layer of cemented sandstone, and cement contains about 14% of potassium oxide. So it's called phosphorite plate. Also, if there are technologies, if there are economic interest, could be potential object. And also Soviet time scientific investigations of the our coastal terragenous deposits of the Baltic Sea, defined marine heavy minerals such as ilmenite, magnetite in the coastal zone. It's also, as far also in literature, it could be regarded as potential geological object. So based on this, the Lithuanian Action Plan for General Exploration and Critical Raw Materials and Minerals until the year 2030 has been set. The idea after this, as we were not allowed to call it like separate research programs, so because of legislation, so by content, we're starting not from scratch, but from revision or, let's say, of available data in the light of recent technologies and recent knowledges and findings. So shortly, the main objectives of this action plan. So at first, of course, the major is to assess the potential of critical raw materials and the minerals in general, if it exists. So, and some subtasks, so to identify, assess the major geological objects. Maybe after some studies, we will change the three major or supply with more potentially prospective geological strata or objects. So to carry out the evaluation of international best practices and collection of information. So it's very important because it has to be evaluated, taking in the consideration also economic. So it means technologies and recent trends, what's going on in the most advanced countries and countries with, as Portugal said, 1,000 years of mining. By the way, Portugal has not yet approved national exploration program. And so another task is to carry out the collection of metadata and metadata first of sources which might contain data which we are required for future investigations, to implement data digitization and structuring, reinterpretation, to carry out processing, interpretation of collected data, and also to collect with our resources, no separate funding, no very dedicated human resources, new samples of core and new samples of brine, and to collect new data. And the second task is to prepare a recommendation for future necessity of preparation of national general exploration program in terms already what is understood industrial exploration program for certain deposit for critical raw materials and critical raw material minerals. And here you see the, perhaps just someone has to stop me checking the time. So there are major objectives of these two major tasks. So I will not go through details, but so this is very important. So analysis of international best practices, collection of information. And so this year and second year we focus on this, and result will be inventory of literature, data reviews, and during this, let's say, this year and beginning of next year, we have to define some for ourselves, some criteria on which we prioritize the, let's say, further research directions in terms of geological objects, in terms of territory of Lithuania. So, of course, so work systematization, collection, digitization of archive data. And so we have, as most of also your countries, so quite rich archive theoretical and what I call practical of geological, geophysical, geochemical data. So we have to see, are these data still valuable? How can we process and reinterpret them? In overall, what we can do with them for future investigations. For the moment, there are these three objects, so sedimentary, crystalline basement rocks, and brine. So result will be preliminary digital metadata, new data list, and identification priorities. What I mentioned, both territories, both objects. So later on, processing and interpretation of digitized and collected data. And here we include also collection, how it's possible. With the core would be easy, with groundwater brine samples, it's possible until, because we have oil production still ongoing. So this is a plan that we can maybe agree and get these samples from the Cambrian, from the depth about 2 kilometers. Or less, but kilometer, close to 2 kilometers depth without financing. So, but that's our challenge. So, and also to compile a data sets of newly obtained data and analytic data. And of course, the beginning of 2030 would be for preparation of conclusions of this, what we collected, our geological data, and prepare more geological recommendations for future direct geological investigation. That's our legal terminology. It means for drilling, for real geochemical, geophysical campaigns, which are costly and time consuming. And for the second and third quarters of the 2030, by the end of our program, we have to provide formal recommendations for decision makers, for government, on the need of preparation of future general critical raw materials exploration program. What I mean in terms of what is now defined by legislation as exploration. But just once again, that does not mean that our companies or international companies could not come and conduct prognosis and exploration, general or targeted exploration for any materials in Lithuania on existing our legislation. So it does not mean that no one from industry could not come until the end of 2030. So, and data sources, apart from all reports and literature sources, what I mentioned it, we have Lithuania Geological Survey has as information center with core storage, and we have more than 1,000 wells, more than 100 kilometers total length. Not all of them, of course, has a core from crystalline basement, but due to the previous drilling, due to the iron ore, we have quite rich, I think, considering our depth, and also maybe due to the oil exploration in Western Lithuania, we have some crystalline basement core, and we have sedimentary succession core. Not maybe very equal coverage for all the territory of Lithuania. And also we have what is now maybe most important, so gravity and magnetic data. So we have the raw data of surveying from raw data catalogs and references, observation points, what you can see here. Also we have maps and interpretation and grids of these maps. We have for Western Lithuania quite and part of Southwestern also seismic data. And what is petrological, geochemical data in the reports in our archive. So thank you for listening and for your attention.
Thank you, Jurga. So Jurga can't stay here for long. So if anybody has any questions, then now is the time.
May I ask,
Yeah.
what is the content of magnesium in dolomite and how do you extract the magnesium from the dolomite?
If honestly, I cannot answer both of your questions. There are some technologies, so people worked on this. There are technologies somehow to get magnesium from dolomite. If they are economic and industry would be interested, I cannot say. And for exact, how to say, I have to look at the reports. So at the moment, I'm not in the office. I'm a bit off. So I will share with Kairi can share my email. Just send me, and we provide more detailed geological and geochemical composition of this dolomite.
Kairi, start küsida.
I only wanted to ask that as your program is already published, can we share it also among the people here if they want to later?
Yeah, our program is in Lithuanian for the moment. And there are, of course, I can share slides and there are links. There could be not maybe problems to translate via all our artificial intelligence. But as I know, and that would be for all countries, the European Commission is preparing official translations of all the member states' programs. So we provided for them, Jolanta, a couple of months ago, yeah, so beginning of March for commission. So soon it could be possible get normal, okay, official translation. So, and we immediately will share. And for the moment in our website, there is, okay, in our language.
Okay, thank you.
Any other
Yeah,
questions?
and that's also explanation because we are under Ministry of Environment, and there is also we cannot officially translate ourselves. I think I can, Jolanta can, but officially we have to have official translations either by governmental, but it's better, I think, that European Commission Translation Bureau will translate. So we can wait a little bit until normal good translation.
So any other questions? If not at the moment, then thank you, Jurga.
So thank you.
Thank you. And we will continue with Latvia. Taiga.
Hello to everyone. Thank you, Jurgen. So I will share my screen. My name is Daiga Pipira, and I am the head of the Geology Department at the Latvian Environment, Geology and Meteorology Center. And in this presentation, I will briefly introduce the Latvian National Exploration Program, which has been prepared in line with the EU Critical Raw Material Act. And in this presentation, I also borrowed some images from colleagues of University of Latvia who are doing important research. So thank you. And this slide is regarding responsible institutions. So Latvian National Exploration Program is prepared by us, Latvian Environment, Geology and Meteorology Center, or LVGMC. And we work together with the Ministry of Economics and the Ministry of Climate and Energy. However, since the submission of the program, the roles of the ministries in implementing the Critical Raw Material Act have changed, so we have to adapt accordingly and change our strategy a bit regarding implementation of this program. And we are also happy to cooperate with the University of Latvia, which has supported us with advice on the program areas and activities. So regarding geological framework, these images will be familiar to most of you, and they also illustrate some of the main challenges we face in the program. So most of Latvia is covered by 6 sedimentary cover, which contain mainly non-metallic mineral resources. However, potential for critical raw materials is linked to the crystalline basement. And so crystalline basement lies at very different depths, to almost 2 kilometers in the southwestern Latvia. The National Exploration Program focuses on 2 main areas with possible critical raw material potential. So the first area is the iron ore belt, which runs from north to south across Latvia. In this belt, manganese and cobalt are already known to be present, and this area is included in the program based on a research project by university on the ore potential of the iron ore belt in central and eastern Latvia. And the second area is the southern part of the Kurzeme or Riga batholith in western Latvia, which is a large magmatic body. But it is of special interest because of indications of potential nickel, copper, and platinum group elements. And as a part of the program, EU member states are required to clearly show what data will be collected and analyzed. First, we plan to analyze existing information from the State Geological Fund, historical geological maps, deep boreholes, and geophysical surveys, as well as available drill cores. The program also includes new geophysical surveys, such as magnetometry, groundmetry, and as well as mineralogical and geochemical studies. All these activities would help us to identify priority areas for next steps, including the drilling of new boreholes. So regarding existing data, here you can see the geological data from State Geological Fund and drill core storage. Most of these data were collected during Soviet period, and geological maps and reports are stored at the archive. At the same time, it is important to note that potential of critical raw materials has not been confirmed, and this is also because of limited number of boreholes, and these boreholes are often not deep enough, and there is no active geological mapping in Latvia at present. And most of these boreholes were drilled between 60s and 80s. As I said, number is limited, and for this reason, critical raw materials potential of crystalline basement is still not confirmed. Regarding geophysical data, we also have historical magnetic gravity and seismic data, as well as borehole geophysics for many deep boreholes. Most historical data are available only as interpretations and often exist only on paper or scanned copies. Another important part of the program is the data management plan. And the main goal of our data management plan is to improve how geological data are stored and accessed. At the same time, considerable work is still needed to digitize existing information, reprocess and analyze data. And regarding priorities, we have also identified several priority actions that could already be started depending on available funding. One main priority is to improve geological information system by checking data quality, organizing existing data sets, and making them easier to access. And another important task is reprocessing and verification of magnetic data from the Kurzeme batholith. This includes digitizing older measurements and checking them against new field data. So this is another important part of national exploration program, so stakeholder engagement. So we cooperate with government institutions as well as Investment and Development Agency of Latvia. We also cooperate with University of Latvia, and of course we are also happy to be a part of the Baltic Basement Work Group. So thank you very much.
Thank you, Taiga. So does anybody has questions for Taiga? Johannes.
You mentioned that there will be some geophysical surveys as well as drilling. Is it right now just like the plan on paper, or is there some timeline also, or it's more like a dream?
It's thank you. It's the plan on paper, because we have included all the activities which we consider as important to implement this program. But we will start with existing geological data.
Anybody else? No. All right, then
Thanks.
Thank you, Taiga. So now we will continue with Estonia, and I will be presenting the overview of this program. So let me set up the presentation. Right, seems to work. So, as I'm the last now, it's a bit easier because I don't have to talk so much about the background, and I could make a shorter presentation. Regarding the Estonian exploration program, good news is that we do have one. So it was prepared by ECT in 2025. Of course, we involved different experts also from the different universities, from the University of Tartu and from TalTech, who helped a lot. And then we presented this program to the Ministry of Climate, and the program was approved by the Minister of Energy and Environment in July of 25. So, all right, there may be some confusion because I said that we presented this to the Minister of Climate, but there are two ministers in this ministry, so one of them is this one. Right. So our program consists of existing knowledge. I would say that this is the biggest part of the program. Then we have defined the focus of the program. We have the action plan, implementation arrangements, and then also the information how to update the program if needed. And exactly as in Latvia, we are also focusing our program on the crystalline basement. So when you had the tour, I guess you noticed that we have also some critical raw materials in our sedimentary cover, like phosphorite. There are also occurrences of vanadium in this black shale, and we have also dolomite in Estonia that contains about 21% of magnesium oxide. So there is that, but the reason why we focused on the crystalline basement is that all these deposits and occurrences are geologically well known. So there's not much to search for or explore there. So there are other problems, not the geological uncertainty. So we are focusing on the crystalline basement where we don't have that much knowledge, and where there is the highest potential is to discover new occurrences or deposits of critical raw materials. And you can see here a map. Maybe it's a bit small, but it's from the program. There you can see there's some defined areas, but actually we don't have very strictly defined exploration areas in our program. This is more like a suggestion, but we are actually considering the whole Northern Estonia as the area of interest in our program. And of course, when we are choosing our targets, we look the analysis from Sweden and Finland to compare our crystalline basement with. So that's that. And it's also said in the program that we are not aiming to define deposits at the moment because there is not enough data for that, and we are aiming to find new occurrences or define the occurrences better. So our program is at the moment with the perspective to 2040, but actually the action plan is until 2030. And the action plan contains also a timeline and budget, but I will talk about that later. So actually in Estonia, the institution responsible for implementing the critical national exploration program is Ministry of Climate. But it is agreed that Geological Survey of Estonia is the main government body who is implementing this program. But we are also involving different universities and institutions who have necessary competencies to fulfill these tasks that are defined in the program. Our program is reviewed every 5 years if necessary. It's strictly from the Critical Raw Materials Act, so it's mandatory. And when we would implement all the activities that are in our program, then the first 5 years would cost around 9.8 million euros. But I have to say that as the other countries, we didn't get the funding from the start. So all these timelines and the funding and everything isn't actually real at the moment. And everything will shift. So when we don't have the money, we have to postpone the activities that are defined in the program. It's also written so in the program. But it's not all bad news. So it is true that we have also had some decades of gap in exploration of crystalline basement. I can't say that nothing was done in these years, but it wasn't very active in these decades. But when the Geological Survey of Estonia was re-established, I would say in 2018, we started with exploring crystalline basement again. We started with the Jõhvi project, and now there are different ongoing activities. We are also digitizing our data and systemizing it and putting it into databases. And we have one Horizon project called Explore, where Taltech is also involved, that deals with crystalline basement and some novel exploration techniques, I would say. But for the most part, until now, our efforts have gone for securing funding for the program. So we have applied for funding in Horizon program, but also in different national funds. And good news is that we recently, at the moment I have to say that the Ministry of Climate recently secured funding for the first part of the program, and it is 806,000 euros. It's for exploration in Uljaste-Sonde area, where we look more deeply into this specified area. We gather the old information we have, and we're also planning drilling there. So we are planning to drill 2 inclined holes there around, I would say, 800 meters each. We hope so, at least. And so, but going forward, of course, if we want to implement this program, we need more funding and more secure funding so we could achieve our goals. So actually, this is the whole plan we have in one table. There are these different topics, activities, and timeline, and also cost. But as I said, it's not like valid anymore because it should have started in the middle of last year, but we didn't, and we are not working on all the tasks at the moment. So it's a good plan, but we can't achieve all these goals in the timeline that was defined in the program. But I'm really glad that we got this funding for this first part, and I think that we can go forward from there. Thank you. So, any questions?
Yeah, I have a question. You mentioned that you got the funding for one site investigation. Are you planning also to drill, or what is the plans for this particular area to study?
Okay, sorry. Actually, there was a question from the audience as well, but maybe I answer. So Taiga, yeah, we are planning to drill. We are. Your question was that if we are planning to drill or. Yeah, okay. We are planning to drill 2 inclined boreholes, and each is around 800 meters deep or long, I would say. But that's the plan. That's the plan. We'll see how it goes. So, and you were asking where did the money come from? Yeah, it wasn't from directly from the government. It is project based, and we got the money from the Environmental Investment Center, actually. Yeah.
Like climate something funding.
Yeah.
Climate action or.
Yeah.
What was it?
It was some CO2 money, actually. Any other questions?
Are you focusing on all the critical? We have like magnesium, iron, and rare earths, or only iron, for example, occurs?
We are actually not focusing on iron at all because iron isn't critical, but there is like a huge, I would say, a huge range of elements that we are looking at. It's also defined in our program, and we chose the elements that can be found in similar conditions in Sweden and Finland, and then we are looking for the same elements in Estonia.
With the particular project, we focus on sulfide mineralization.
Yeah.
And the possible related elements. Because there are some tellurides and some interesting stuff, but we know only very bits and pieces, and we want to know that.
But your iron deposits are empty, like they're more big, because in the Varena, it's like we have rare earths, iron.
Yeah,
and
this is
phosphorus
different. We don't have apatite, we don't have rare earths. There is just small occurrences of also sulfide mineralization. But then there are, okay, this is not critical minerals, but there are some small veinlets of gold and silver, and some sulfur salts and tellurides of unknown age, unknown paragenesis, and so on. Everything is unknown.
All right. Any other questions? Maybe from online? No. Okay. Then thank you, everybody.